Today we'll be discussing about Numpy. So the agenda for this video is we'll discuss why we use Numpy, why we use Numpy. Then we'll see why it is quicker than Python. Then we'll see the import syntax. We will then look at the Numpy properties, the array properties. We'll look at something called axis. It's in which direction we perform the operation. Then we'll look at ranges. Then type conversion. Then CRUD operations. And then we'll look at some filtering operations as well. We use Numpy for faster operations, for faster list operations. If we look at the traditional Python list, we have something like L equal to say 1, 2, 3, 4, and if we want to say perform an operation on this, say we want to square each element in the list, so then we have to iterate over each element in the list, and only then we can perform the operation. So something like let's say we square it for I in L. Now if we print L2, we have the operation. Now if we look at the time it takes for this to happen, percent time it. So as you can see, this took around 361 nanoseconds, right? But if we use Numpy, we can do this in much quicker way. L2 Numpy dot array and the syntax is also shorter. We can do just something like this, percent time it. Come on. This is effective for larger lists. So let's say we take a range of 10,000. So that took about 1 milliseconds. Well, we see Numpy took about 8 microseconds, which is way faster. So that's one of the primary reasons why we use Numpy. It's both shorter syntax wise as well as far quicker than traditional Python lists. The reason why Numpy is faster is because under the hood it uses C language, which is a very low level language compared to Python, and also it does parallel processing. And the other reason is all Numpy arrays the elements are in contiguous memory locations. The what this means is so what this means is, suppose this is the these are the memory locations. Python has heterogeneous supports heterogeneous data types, which means you can have an int here, you can have a float, you can have a string, you can have a boolean. All these are references, and you can have them side by side. You can have the list stores them side by side, which is so while accessing it, it's inefficient. Reasons why it is slow. But NumPy does not support heterogeneous data types. It only supports homogeneous data types, which means all are of the same data type. So you have ints side by side, or you have strings side by side. And this is one of the reasons. This is the other reason why it is quicker. So that's the reason why we use NumPy. That's the reason why it's quicker. Now the syntax is pretty straightforward. You have import NumPy as np, and we use this np dot, and we use this to access methods. The some common array properties. If you want to check the dimensions, like if it's a 2D array or a 3D array or a 1D array, we can use the property ndim, and sorry, the array l2 dot ndim. Okay, so we do l2 dot. If you want to see the shape of this, it's a 1D array, and it basically has 10,000 elements in that 1D array. Now if we check at ndim, it's one dimension. So if we want to create a 2-dimension NumPy array, we do np dot array 1 2 3 4 that l2 dot shape. You have 2 cross 2, and we have 2 dimensions. So next we'll look at, so those are some common properties. Now let's look at some let's look at access. So access is basically in which direction you want to perform the operation. So we can let's see. So let's look at the array. So if you see the array has a length over here. Sorry, it has a vertical dimension and a horizontal dimension for a 2D array. So generally for a 1D array, the access 0 is, let me just write it. Yeah, for 1D, the rules are for 1D array, the you have only one axis, so and that axis is called axis 0 on the which goes along this side. But if you have a 2D array, the axis 0 is vertical and axis 1 is called horizontal. Don't think of them as rows and columns, just think of them as vertical and horizontal. And if it's a 3D array, you will have um, 1, 2, so you will have uh, vertical as axis 0, horizontal as axis 1, and the depth is called axis 2. So that's about axis. We'll see that in more detail in the examples. Then let's come to ranges. Typical Python range would be something like range. We can have one. Can say 10 of them, 10 elements. We get 10 elements. And in Numpy, we have a similar function, np.arange, which does pretty much the same thing, but it's a Numpy array. It's a Numpy range. So just like Python range, you can set the start, stop, and step size as well. So we can say start, stop, step. This would be so let's say start is 4, stop is about 8, maybe 28, and step size 2. So we get all the you can say even numbers starting from 4 until 28. You have a similar functionality in Numpy. You can do arange, and it'll give the same thing. It has similar functionality. Arange. Alright, np.arange. So as you can see, that's the Numpy equivalent. The one advantage that you have in Numpy range is that it supports floats as step size. So we can do something like L4 equal to np.arange. So say 428, and step size can be something like 1.5. So as you can see, you get float values. You can get a float list, and that's about ranges. Let's look at type conversion. Something like str. If you see L, everything is converted to a string. In Numpy, what you can do is you can do listwise operation. There is no listwise operation in or rather list level operation. in Python. So in Numpy, that's one of the advantages you get. So if you see L is np dot a range, say 10 of them. So what you can do is L dot as type float 64. So that's one of those with string. Okay, it's str. So as you can see, we can quickly convert an integer list to a string list without using any iterators, and that is type conversion. Now let's look at CRUD operations. And it lists in Python. This is a we use something like L. We use the index to get the element. So if we say L4, we get the fourth item from the list. And we can use list slicing as well in standard Python. Something like if we want to get the last 4 elements, so we can set something like length of list -4 to converting everything. So as you can see, we got 6, 7, 8, 9. We can also use negative indexing. So I guess -4 to, no, is it not -4? So that is negative indexing in standard Python. Now we can do similar things in Numpy. Numpy access, we can do something like L equal to np dot a range can you can say 4, which is similar to Python. We get the same thing. Now if we want to do slicing, we can do something like L -4 to the end, and we get a Numpy array. So that is slicing. So next we will look at filtering. It's also called as masking in Numpy. So traditionally in Python lists, you can filter elements after iteration and adding some conditional statements. Something like, let's say if you have a list like this, so we can say for I in range, for I in L, if we want to say filter all even elements, so we have to do something like if x mod 2 is 0, print x, and this will print all the even so this will print all the even elements, and if we want all of them in a list, then we'll probably have to create another list called L2, and then L2 dot append x, and then we have to print L2. And so this is the traditional process in Python. In Numpy, this gets pretty simple. So np dot a range 10. So if we want to filter this, what we can do is we can use something called masking. Before that, there is something called Boolean masking. What the setup it uses, or rather the operation, what do you call this? The type of operation is Boolean masking. So say if we suppose do length, so we want to get all elements less than 4. So as you can see here, true, 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 false. So you get a Boolean array. So what's happening here is it considers all the true values, all the indices of true values, and discards all the false values in the Boolean masking. So what this does is, if we say L less than 4, it gives you 0, 1, 2, 3. These are all the true values. And we can use much more complex logic, something like if we want to do, if we want to set multiple conditions, say L less than 4, so L less than 8, and L mod, so, and we want all the even elements less than 8. Truth, right. Okay. So we have to make sure we add braces. So as you can see here, the first element is true because it's less than 8, and it is mod 2. This is true because 0 is just considered true, and false because it's the first element. So it's the 1 is not even, so it's false. 2 is even, so it's true. 3 is odd, so false. And if you see here, it goes to false, false, and false because these are all greater than 8. And so if we apply this logic to the list, and if we filter this, we will get 0, 2, 4, 6. And that is the filtering part. That's it for today. Thank you.